Three formulas exist for exponential growth decay type questions, and I'm going to use the purple formulas instead of what the book is using. And interesting enough, all three equations are derived from this last equation, where you have an amount and you have a beginning amount. R is the rate, N is the number of times compounded in 1 year, and T is the time in years. You could have time in terms of weeks, but then your rate must be a weekly rate. So notice going from compounded interest to the regular exponential growth decay, N is equal to 1. Plug in an N in will give you that same exact equation. And if you were to look at Euler's number and do a substitution, you would see you'd be able to go from compound interest to continuous interest. Notice the keyword continuous interest. A equals PE to the RT. Also notice that that RT should be in parentheses when you use your calculator, R times T. In this problem, you would see that you have a rate of 25% per week, and the question is in 6 weeks. Notice the time and the compounded are in the same units. Starting with the compounded interest formula, notice that you can get Euler's number by taking a limit situation, and you can see as x gets larger that your number E, which doesn't repeat or doesn't terminate, is equal to 2.718 approximately. And furthermore, going from one formula to the next, you would start with the compound interest formula, substitute in. This is where you take the limit as to get Euler's number, substitute it in, and you end up with the interest. So that's a proof going from one formula to the next. Now I'm going to do a few problems at the end just to use those three equations. First of all, we're looking at a balance after 10 years of an investment. So in this case, you're solving for A, starting with 5,000, and it says compounded continuous, so it's going to be E to the R, which is the rate, 0.0085, correction, 0.085. Moving the decimal 2 places to the left, change that into a decimal, and then that is going to be times 10. So we're going to put that in parentheses when you use your calculator. On the second one, it says compounded quarterly, starting with the same amount, 5,000, and the rate is the same. Quarterly 4 times in a year, so it's going to be 4 times 10. 10 number is the number of years, and again putting that in parentheses. Comparing the two, and you're going to see compounding continuous means it's continuous every millisecond, and therefore it's going to be compounded more often, and this is going to be a larger number as it compounds on itself more often. Going to the second problem, it's going from 2007 to 2020. Now, you're basically looking for the difference of those two numbers, so you're looking at 13-year difference. There isn't any compounded, so your N is really equal to 1 here. Therefore, your ending amount is going to equal the beginning amount times 1 plus the rate. Now notice on this rate, moving 2 decimal places to the left gives you 0.005, so be real careful with those rates. And then it's just going to be the time, which is 13 years. Straightforward problem involving an annual rate. Next, we're going to look at rabbits and increasing 10% each month over the last year, so every month. Now, this is not a compounded situation. It's not saying it has an annual rate of 10% compounded monthly. It's just saying that it's compounded 10% each month. So I want to put my head around just the months. Then when it talks about for 1 year, I'm really talking about 12 months. So looking at this, I am thinking about months. I'm starting with 10, and then it's going to be times 1 plus 10%. Again, talking months, and then no compounded, but how many months in a year? 12 months, so it's going to be to the 12th power. And that's going to give you your final number of rabbits. Of course, you would round to the nearest whole number or round down, justify it however you want, because you're not going to have any partial rabbits. This is using the 3 compound exponential formulas and solving equations with them.